Hi guys, welcome to my NLP series. So we'll be continuing with the lecture for today, which is gradient descent. So guys, as you know that we need to quickly move to the stage where we start leveraging LLMs and switch to modern NLP. But guys, the main core of everything is gradient descent. So I thought let's make a separate and dedicated video to it. So guys, in simple term, we'll start with what is gradient descent. So guys, see, gradient descent is nothing but it is an algorithm. So it's an algorithm. So what does this algorithm does? It basically helps me find optimal value of weights. So what does this mean? So guys, see, what happens is that in my last lectures I have been giving you a lot of touch base on gradient descent, but I haven't fully discussed it. Maybe I have discussed it, but still I wanted to have a separate lecture. We are seeing this equation everywhere, that W old eta loss function with respect to W old. So we have been seeing this equation a lot, guys, right? So what we are saying is that the new updated weight would be W old minus this hyperparameter. So what is this hyperparameter called as? Hyperparameter called as, this is called as eta, and this is essentially learning rate. So first of all, whenever we say that a model is learning, what does that mean? So this word learning means that it is learning to find the right values of weights. Why do we need to find the right value of weights, guys? We have been talking about logistic regression a bit. So we've been talking about logistic regression, and I've shown you how we write this x is equal to z, x is equal to, sorry, z is equal to zw plus b. So x is something that we know. We need to find w vector. So what is w? It's nothing but it's these weights. Okay, these are the parameters. Now this is where, in order to compute the optimal value of the parameters, we tend to use gradient descent, which is absolutely clear. Now let's move ahead and try to understand a little bit more about gradient descent. The thing is simple, guys. I don't want to make it complex like other people do. Let's just start with a simple graph. So there's a loss function, and there is, so what will happen is you need to find weights. So let's say, to start with, you pick up a weight that is W1. So assume that the loss is this. So you are starting with a loss function. Okay, you're starting with the loss function and you're starting with the random value of it. Okay, so let me write these steps. These are essential steps so that you can understand better. So we start with a random value of weight. Random value of weight. Okay, and then we compute the value of loss function. Then we compute the value of loss function in context of that weight. So guys, see, there are only two situations, right? Either I need to increase my weight, the value of weight, or I need to decrease it. There is no third option, right? Obviously there would be an option that I don't change it, but let's assume we are starting on our optimization journey and we need to find the optimal value of w for which the loss function is minimal. So we've started with w1. So let's do one thing. Let's just draw a tangent. Okay, let's draw a tangent. Okay, yes, there is some bit of maths, but it's okay. You can even skip it. As I said, it's not super compulsory, but still good to know. So let's just draw a tangent. So we have drawn a tangent over here. Okay, now what does this mean? Let's just try to see that what is the angle that it makes with the x-axis. So for that, let me draw a line and see, this angle is more than 90 degree. Okay, so if you would have studied trigonometry in class 10th, you would know that tan theta from 90 to 180 degree. Okay, when the value of theta is in this range, it is negative. So whenever you are in the negative direction, okay, so whenever you are in the negative direction, you need to move from, which is this direction, guys, left to right, left to right. So whenever the slope is negative, so let me write out this. Now we started with a random value of weight. We are calculating the value of loss function, and now we analyze the tangent. We analyze the tangent, and if the slope is negative, which in this case is, since it is making an angle of more than 90 degree, we need to move in this direction, left to right. And guys, if it is positive, then we need to move in the direction of right to left. So guys, these are just things, if you know, these are good to know. But as I said, that a lot of modern data scientists, modern AI developers might not need this granular level of details, but still you need to understand basics. So I'm focusing on that as well. So guys, mostly this is it. Now the only thing that you need to understand is we have this equation, right? W, and guys, this process would iterate until your loss finds a optimal value, your loss gets minimized. So guys, see, loss function are essentially of two types. Okay, one is of convex type and the other ones are of non-convex types. Okay, so for the convex loss function, okay, what happens is that for the convex loss function, what happens is, the thing is that there is no issue that comes up. That means there is no local minima. Okay, there is no local minima. That means when we are trying to find out the minimal value, this is relatively simpler. But for a lot of neural networks, guys, we use non-convex function, where the thing is that it has local minimas. So if your algorithm, whatever you are writing up, gets stuck in the local minima, it won't be able to reach to the global minima. So just keep this point in mind. Obviously, if this comes up later on in the course, we'll see and analyze in depth, but for the time being, this much knowledge is okay. So guys, in simple terms, you are able to see, right? The only objective is that we need to find the optimal value of weights. We need to minimize the loss function. For that, we start with random value of weight, and then we try to just use this equation, right? W new is equal to W old minus eta, rate of change of loss function with respect to W old. And this basically is the step size. This is basically, people call it as step size as well, that how fast I need to move, how fast or slow I need to move. So guys, this is a hyperparameter. It essentially tells that how quickly I need to come down the slope, right? So let's say this is the thing, how quickly from here, what should be the next value? Should you move slowly or should you just rampantly go over here? So all these things are dependent on this parameter. This is essentially the step size of it. And guys, if you want to have a better visual understanding of things, so there is a channel, let me tell you the name of the channel. Wait, if I go to my YouTube and we go over here, I think four four blue one brown, I guess is the channel name. Yeah, three blue one brown, sorry. So guys, they also have a video on gradient descent. You can see they have made a good video if it comes to visualization. But guys, even if you skip that, that's okay. Essentially, you need to understand this equation and the core maths behind it. So on this note, I would like to just give you a last summary, that this is the equation that we need to remember. Okay, let me just write it again. W new is equal to W old minus learning rate, rate of change of loss with respect to W old. So see guys, simple. This is the step size, or how fast or slow your gradient descent algorithm would work. All you need to do is you need to find partial derivatives of loss, partial derivatives of loss function with respect to partial derivatives of loss function with respect to weight. And this also guys are done with the help of chain rule. So all this is okay, not a big deal. All you need to do is remember is that, hey, gradient descent is an algorithm that helps me find optimal value of weight. There are variants of gradient descent as well. There is stochastic gradient descent and other forms of things, but guys, mostly these things are done via coding only. So even if you skip the maths, that's absolutely okay. And as I said, that we need to focus more on modern NLP, and the base is LLMs. So guys, even the thing out there is why I tell this is that even I also spend a lot of time on these type of researches. See guys, whenever it comes to LLMs, there are two things which a lot of people miss. That if you go for an open source model, right, people say that we might not even require, there are few people who don't understand the granularity of things because they haven't deployed anything yet. But the thing is that they say we can even use open source models, we don't need to use say endpoints for companies like OpenAI, Anthropic and other things. So they don't understand guys. One thing is these are best models, the accuracy of these models are very high. Number two, from where will you get a computer that would be able to download your 70 billion parameter model? You would go to a cloud, buy a VM and then run it. The next thing is you require knowledge of fine tuning, you require code for that, you again require compute for that. Even post this, after spending so much money, where will you deploy it? How will you assure that the deployment speed is good? How will you do it guys? There are a lot of parameters guys. That is why I'm saying that modern NLP would mostly be, the core of modern NLP would be a API call only, but the way you do it, the way you design the system would be the skill set that would be needed. On how do you efficiently write prompts, okay, even if you're fine tuning any of the advanced models, how do you leverage that skill? So everything will be covered in this course, don't worry. But these are basics, that is why I'm making some short lecture tutorials for someone who's new to this space, who understands and never feels lost, okay. And guys, please try to subscribe to my YouTube channel. If you have any doubts guys, just DM me over LinkedIn and Instagram. I'll be more than happy to clarify all your doubts in a one-to-one session. Have a great day ahead. Thank you friends.